So as the science of chemistry continued to progress, scientists were discovering more and more elements, and they were becoming kind of hard to organize. So there was this need of inventing some kind of chart or method of organizing all of these elements to make them easier to study. So this is how they developed the periodic table as we know it today. So the father of the periodic table is this guy, Dmitri Mendeleev. He listed elements in columns in order of increasing mass, and he arranged the columns so that the elements with the most similar properties were side by side. His table kind of looked like this. He made a periodic table, but he wasn't the first. Actually, a lot of people tried to do this before him. The reason he gets all the credit is that his periodic table was the best. His table was so good that he was able to leave blanks in certain spots of elements that weren't discovered yet, and he was so sure that an element was going to be discovered that would fit neatly in his periodic table that he left blanks, and he was right every single time. So the father of the modern periodic table is this guy, Henry Moseley. He determined the atomic number of atoms of elements, and he said it made more sense to put these elements in order of atomic number rather than atomic mass. And this is what his table looked like, which is what our table looks like. Interesting story about Henry Moseley is that he lived around the time of World War II, and he enlisted against the judgment of his country, England. They didn't want him to fight. He was a very important scientist. He surely would have won a Nobel Prize, but he was a very patriotic man, and he decided that if his countrymen were going to war, he would go to war with them. And he actually died in battle, and since then, Britain had made a law that if you are deemed an important scientist, that you're not allowed to enlist in the military. And since then, a lot of other countries have passed that law as well. So the modern periodic table is arranged in periods and groups. So the periods are the horizontal rows, which means side to side. And if you go across the period in a period on a periodic table, you get what's called a periodic law. This is when the elements are arranged in order of increasing atomic number. There's a periodic repetition of their physical and chemical properties. The groups are the vertical or up and down columns of the elements in the periodic table. And the elements in any group on the periodic table have similar physical and chemical properties as the other elements in that group. So groups 1, 2, and 13 through 18 are called the representative elements. A representative element is either a metal, a nonmetal, or a metalloid. So they call them representative elements because they're a good representation of everything the periodic table of elements has. It has metals, it has nonmetals, and it has metalloids. It has solids, it has liquids, it has gases. All of these things are found in the representative elements. So let's look at the first category, metals. Metals have certain characteristics in common. They have high electrical conductivity. They have high luster. That means they're shiny when they're clean. They look metal-like. They are ductile, which means they can be drawn into wires. You can get things like copper wire for electricity because copper is a metal that has the property of ductility, or it's ductile. Metals are also malleable, which means they can be beaten flat into sheets of metal. With the exception of hydrogen, all of the representative elements on the left side of the periodic table are metals. There are a couple of groups that have special names. So group number 1 are called alkali metals. Group number 2 are called alkali earth metals. Most of the remaining elements that are not in group A are also metals. So those are the transition metals and the intertransition metals. We call those group B elements. So here are the metals. Group 1 here, with the exception of hydrogen, was what we call alkali metals. The reason they're called alkali metals is if you put them in water, not only do they explode, they're very, very reactive, they make an alkaline or a basic solution. Group number 2 are called alkali earth metals. They also make an alkali solution, but they're not as reactive, no explosions. In the middle here, groups 3 through 12 we call transition metals because they are transitioning from the most metal-like properties to the non-metals that we see on the right-hand side of the periodic table. And in the little bottom section you see this little cutout here, that's the inner transition metals. If you follow the atomic numbers, they actually belong after element 57, lanthanum, but before element 72, hafnium. So the reason they're cut out is if these rows were put in, the table would be twice as long and there'd be a big blank space in the middle. So they just cut out those two groups and stick them on the bottom. Because they begin with element 57, lanthanum, and element, can't read that number, 89, actinum, they're sometimes called the lanthanides and actinide series. But you can also call them inner transition metals. Okay, next we have the nonmetals. These occupy the upper right corner of the periodic table. They're generally non-lustrous, which means they're not shiny, and they're poor conductors of electricity. They generally have all the properties opposite of the metals. A lot of them are gases at room temperature, like oxygen and chlorine. Others are brittle solids, like sulfur. It's kind of chalky. You could break it up with your fingers. So there's some special groups you need to know the names. Group number 17, those are the halogens. If you break that word down, halo refers to salt. Gen means like forming. So they're salt formers. Every salt, like say sodium chloride, has a halogen in it. Like chlorine is in group 17. Group 18 are called the noble gases or inert gases. Inert means they are unreactive. So this group contains all gases and they do not take part in chemical reactions, or at least not easily. So there's the nonmetals you see in the black box there. There's group 17, those are the halogens. And there's group 18, the noble gases. Last of the representative elements you need to know about are the metalloids. These are the elements that border the line between metals and nonmetals. They have properties in between metals and nonmetals. So they might be conductive, but they also might be brittle and non-lustrous. They're kind of metal-like, but also kind of non-metal-like, hence the name metalloids. So on your periodic table, you see this black staircase that goes down, over, all the way down past element 84. That's what we're going to call the staircase. Now, elements that are above and below this line are typically metalloids. Now, there's a couple of exceptions. So boron is a metalloid, but aluminum's not. Then elements above and below are, so silicon, germanium metalloids, arsenic, antimony, and tellurium are all metalloids. Now, there's some debate as to whether polonium, PO, is or not. Some books and references will say that it's a metalloid and some won't. We're going to say that it's not because I think the majority will say that it's not. I think the reason is it's just that it's a really rare element and there may not be enough of it to test, or maybe there's just not full agreement on whether it's a metalloid or not. So, rather than memorizing more than 100 elements, you need to only learn the general behavior and trends within the major groups. This is going to give you a working knowledge of the properties of most elements and will help you to answer more questions in the long run. We're obviously not finished with learning about the periodic table, but this is an easy little intro to how to use it. You should know groups and periods and the names of some of the major groups. We're going to learn more about the trends in later chapters and how to use the table more. So let's wrap things up here. A periodic table is an arrangement of the known elements based on similarities and properties. You should know the locations and major categories of the elements, and you should also know that the group numbers of some of the element families, like the alkali, alkali earth, halogens, and noble gases. We'll practice this more in class and lab, and we're going to take our exploration of the periodic table further in later chapters.